Hi, let's learn about color systems. In the color systems, we see that or we come across um, this is subtractive pigments and additive colors. Subtractive pigments are also can be told as subtractive color paints. Okay, so this color and then pigments are different. I just want to once again repeat the colors, okay, and then pigments are different. Okay, they're not same. Okay, so just keep this in mind. So what is pigment is uh, it has a function or it works like this. It observes certain wavelengths and reflect back certain wavelengths. Probably your t-shirt is made with of pigments, okay, and maybe there are dyes and pigments, all this, and maybe there are certain paints that are used with pigments. So uh, there are both are different, that is the pigments are different and as well as colors are different. Okay, uh, now this subtractive pigment systems have come from artists, and this is the very initial one which color system have come up. So in the beginning, when the artists have grew up and where they started painting, they framed this and they defined it that red, yellow, blue are the primary colors. So red, yellow, blue are the primary pigments, okay, in this subtractive pigment system. Now we have another thing also, where we have subtractive paints. Another one is additive lights, additive colors, probably we can call that additive lights. And whereas in subtractive colors, we can see that the yellow, and then magenta, and then cyan. Okay, and then whereas in additive colors it is green, red, blue, which forms to give white, and here it gives black. Now even this subtractive colors are defined, or it has come from a system of printing system, probably your magazines, your newspapers, or all these are come from the CMYK has come from the printing system, where they use paints or pigments in this area also. Now both in the area of this subtractive pigments, that is pigments and paints, we see that these colors can be touched physically, or probably when I go to a painter, I can touch this red color, I can touch this blue color, I can touch this yellow color, I can touch this red color, I can touch this blue color, I can touch this yellow color. Whereas in when I see to this, when I want to try and see this or touch this additive colors, which is not possible. Additive colors are framed or formed by scientists, okay, and they formed, and these colors are formed also with light, the beam of lights that they have. With these lights, okay, you get this additive colors, and probably you'll come across this additive colors in the computer monitors, television monitors, and theaters, all this, where you can see that the beam of lights are being projected, and then with the combination of those lights you see a picture, or you will see a colors on the screen. Okay, be it computer screen, television screen, theater screens. Okay, these only form through additive colors by using beam of lights. Whereas in subtractive colors, they are their primary colors are what is that, magenta, and then cyan, and then yellow. Okay, and which forms all together, mixed together, they give black. And this K is CMYK, where K is also called black, or it is also called key. Okay, so it is also named like that. And these colors can be touched physically. Okay, and another one is these are made by artists. Okay, and in the CMYK, mostly you can see a dots. You can see, I think probably if you go to the newspaper, you can see if you have the newspaper. If you go a little closer to the newspaper, sometimes some papers, you can observe there are dots. With those dots, it forms print. Whereas in here, it forms with pixels, and which forms with pixels. Okay, and let's see what is how this. First, let's see how this additive colors works. In the additive colors, I think this is how when you go to when you go to the when you are at home, we can just go close to the monitor or probably any screen, and you would find this red, green, blue lights. Okay, you can see this, and perhaps sometimes it is also mentioned like this. Okay, where it has red, green, and blue colored lights, which intent form to produce white light. When all the lights are off, the pixel is 0. When all lights are on, the pixel is white. And when there is only half the light properly over it, you could see there's a gray, a neutral. Now only when red is on in this lights, okay, you would see only the red color. When the green is on, you can only see the green color, and blue, you can see only the blue color. Okay, and when you want to see the cyan, both blue and green should be on. I think probably you can see here, this green and blue mixed together, you get what? Cyan. Okay, and when you want to see magenta, which is blue and then red, look at this, blue and then red. This kind of magenta can be sometimes also called purple. Okay, you can see also purple, and this is how you get. See, look at here also, this both red and then blue, you'll get here magenta, which is also like purple. Okay, is formed. So when you mix both, that is blue and then green, both the blue and the red, sorry, the primary colors, both the primary colors, you tend to get this magenta. And as well as when you come across this, if when you want to form yellow color, both red and green are mixed together, you'll see the yellow. And you cannot form any primary colors, that is, by mixing of these two colors, you cannot form red. By mixing of these two colors, you cannot form blue. By mixing of these two colors, you cannot form green. Or by mixing of, in fact, any of those colors, you cannot form the primary colors. Okay, so just keep this in mind, that you cannot form you cannot form a primary colors, okay, by mixture of any of the colors. Okay, so this is how an LED screen or probably a phone a theater, a television works with colors, and with the mixture of these mixing of colors, we tend to see a lot of other colors. Okay, so this is how we can see the millions of colors on the screen only by this fashion. An interesting part now we can see in the subtractive colors. Subtractive colors, where you can see in the CMYK, that is cyan and magenta and then yellow. Where it forms in the center is black, and when magenta and yellow forms, you can see red, or mix, you can see red. When cyan and yellow mix, you can see green. When blue, or sorry, when cyan and then magenta mix, you can see blue. So this is how the combinations of CMYK works. Now let's check that when a person is wearing a blue t-shirt, okay, under the sun, probably a white light, which carries the primary colors of red, green, blue in the white light, and this blue t-shirt person is reflecting only the blue color to our eyes. Let me come back, let me tell you again this. So when a person is wearing a blue t-shirt and is walking under the sun, he is having the there is a white light falling on him, okay, and this white light contains of red, green and blue, and when it hits this blue t-shirt, you can only see the blue color. That means the red and green are observed by the blue t-shirt. Okay, so both the red and green are observed. Okay, so, and that's where you can only see he's able to see only the blue t-shirt. Okay, now let me go a little further and see another example. You have another again white light, or probably we are actually sending this green, so red, green, blue through an yellow filter, okay, which is placed here. When the yellow filter is placed, we can observe here only the red and green lights are passed through it. That means, look at here, in the yellow, you can see here, in the yellow, you can see here only the green and red are present, whereas in blue is, what happened? The blue is observed, okay, but these both are reflected. So these both are reflected and this is observed. Okay, and when again another filter is placed, which is of cyan filter is placed here, we can see only the green is reflected. Now let's come back here. Now let's see the cyan. In the cyan, if you see, you can see that blue and green are reflected, but the red is, what's happening to the red? It's been observed. Okay, so that's the reason in the red and green light are present when it is passing through the cyan filter. Only the green is passed through, the red is observed. Okay, so this is how the subtractive pigments work. Okay, so this is how the subtractive pigments work, And uh, probably I can tell you a little more that in the Xeon, okay, where you can see that blue and then green are accepted, but the red is, what's happened, it is uh, observed, okay. Whereas in yellow, where this they accept green and red but not blue, okay. In magenta it accepts blue and red but not green, and that's how they're called subtractive colors, okay. And this is how the subtractive colors works. And we saw that additive colors, they mix together, form white, okay. And then we saw the different mixtures of light, okay. When they're neutral, you can see that we can see the gray is formed, okay. And then we saw how red, green, blue is formed, okay. And then how cyan and then magenta and then yellow is also formed with combination of two colors here and then we have even saw that every monitor has such a kind of pixels in the system. So when you go closer to it, you can find this, and this is how the additive colors work. So this is how the additive colors work, okay. And you can find millions of colors formed on the on the monitors, okay. Millions of colors with different combinations. You can see millions of colors is being formed. This is how the additive colors work, and we have seen here the subtractive colors, how they have worked. And as I told you, in subtractive colors, these are the subtractive pigments. I'm very sorry for this. The subtractive pigments. Okay, in the subtractive pigments or paints, we can tell also paints, that there are wavelengths it is observed and other wavelengths are reflected, okay. And we have seen this example here where when a person is wearing a blue t-shirt, that he's under a white light where he has red, green, blue colors are being hitting him. And then we saw that both the red and green are absorbed, and then only the blue is reflected to the human's eye, okay. So these both are absorbed, and we can see here that this again the white light is being sent through the yellow filter, and where we can see that in the yellow filter both this is green and red is accepted, but blue is not accepted. And in the cyan, we can see that in the cyan where we can see that green and then blue is accepted but not red. So the red is not accepted, only the green is allowed. So we can only see here in green color. So this is how the pigments